Even though it sounds like the stuff of science fiction, there has been a new discovery by scientists to travel faster than light, proving that spaceships traveling at warp speed is possible. Space explorers have long sought a technique to travel faster than light in order to reach deep space faster. In general, all of the ways revealed have substantial flaws. However, scientists have developed a new method. In today's video, we will be discussing the newly discovered way to travel faster than light, how it works, and how soon it will be ready for use. So grab a drink and let's get into it. The universe is so huge that light can travel for thousands of years from one end to the other. For example, light travels from the moon to our eyes in about 1 second, implying that the moon is 1 light second away. Sunlight, on the other hand, takes longer to reach our eyes, taking roughly 8 minutes to reach us, implying that the sun is about 8 light minutes distant. The light from Alpha Centauri, our nearest star system, takes 4.3 years to reach us. Hence, Alpha Centauri is 4.3 light years away. Other stars and things outside our solar system can be found at distances ranging from a few light years to a few billion light years. This is why what astronomers see in the far reaches of the universe is history. The M drive, which was built as a device that would whisk humans to the farthest reaches of the universe in record time, had chanced upon this very phenomenon. Theoretically, this patent-pending technology works by trapping microwaves in a shaped chamber, where their bouncing produces propulsion. The chamber is closed, so it will appear to move without any fuel input or thrust from the outside. The M drive is based on Newton's second law, which states that force is defined as the rate at which momentum changes. As a result, an electromagnetic or EM wave moving at the speed of light has a certain momentum that will transfer to a reflector, producing some force. The M drive, which sounds simple, is enabled by this accumulated small force in large quantities. No known object can travel faster than the speed of light in vacuum, which is 299,792 kilometers per second, according to Albert Einstein's special theory of relativity. Because of this speed restriction, it is doubtful that humans will ever be able to send spacecrafts beyond our Milky Way's immediate neighborhood. However, a new study from the University of Göttingen's Erik Lentz reveals that there may be a method to get beyond this barrier. The catch is that the plan demands a tremendous amount of energy and may not be capable of propelling a spacecraft. Traditional energy sources, according to Lentz, may be capable of structuring the structure of space-time in the form of a soliton, a powerful solitary wave. This soliton would function as a warp bubble, compressing space in front of it while expanding the space behind it. Space-time, unlike anything within it, can bend, expand, or warp at any speed. As a result, a spaceship trapped in a hyper-fast bubble may travel faster than light in normal space without violating any physical constraints, including Einstein's cosmic speed limit. Now, the concept of manufacturing warp bubbles isn't new. It was first presented in 1994 by Mexican scientist Miguel Alcubierre, who dubbed them warp drives in reference to the Star Trek sci-fi series. Until Lentz's findings, it was considered that the only method to make a warp drive was to generate massive amounts of negative energy, potentially through the use of undiscovered exotic matter or dark energy manipulation. To solve this challenge, Lentz devised a previously unknown geometric structure of space-time, from which he derived a novel family of solutions to Einstein's general relativity equations, which are also known as positive energy solutions. Since then, a few variations have been proposed, including a 2010 update to the Alcubierre drive's physical design by Dr. Harold G. Sonny White, a former NASA engineer. His revision reduced the required energy to a more manageable level, yet it was still impractical because the method still required exotic matter, albeit in less quantities than the Alcubierre system. Another group of Swiss researchers known as Applied Physics, or APL, proposed their own idea. Surprisingly, their drive's warp bubble was created without the use of any unique materials. Their model, however, was unable to move faster than the speed of light, which is the holy grail of space travel. To show how this idea differs from others already offered, Lentz begins by describing the physical structure of the classic Alcubierre drive, which is the foundation for practically all other solutions. The Alcubierre method, he claimed, presented an intuitive image of what a warp drive would do: constrict the space directly in front of the center region housing the ship or vehicle, and expand the space immediately behind it. The warp drive is depicted here as a curved wave that a spacecraft will ride to its destination on. Despite the fact that it provides the foundation of warp travel, Lentz contends that it is not even the most important element. To better understand this new discovery, we have to also understand the concept behind the warp drive. Recent spacecrafts are currently limited to the laws of standard Einsteinian physics. For example, to accelerate a ship, you have to apply force in the opposite direction to the one in which you want to travel. Throughout the history of aviation and aeronautics, this meant burning fuel and shooting them out of the back of a ship in a vigorous physical reaction. The limitation of this approach is that eventually you run out of stuff to throw. The other limitation is that your ship is still subject to Einstein's equation describing special relativity, which states that as you approach the speed of light, more and more of the energy you expend goes into increasing your own mass until you reach the point where no matter how much more energy you put in, you cannot go any faster, and you never quite reach the speed of light. It's impossible to accelerate faster than light using standard physics, because your ship just gets more massive as you put more energy in it, and it eventually gets so massive that you can't do anything more with it. Though Lentz's solutions appear to conform to Einstein's general theory of relativity and remove the need to create negative energy, space agencies will not be building warp drives anytime soon, if ever. Now, part of the reason is that Lentz's positive energy warp drive requires a huge amount of energy. A 100 meteor radius spacecraft would require the energy equivalent to hundreds of times the mass of the planet Jupiter, according to Lentz. He adds that to be practical, this requirement would have to be reduced by about 30 orders of magnitude to be on par with the output of a modern nuclear fission reactor. Lentz is currently exploring existing energy-saving schemes to see if the energy required can be reduced to a practical level. Any warp drive would also need to overcome several other serious issues. Alcubierre, who regards Lentz's work as a significant development, cites the horizon problem as one of the most pernicious. A warp bubble traveling faster than light cannot be created from inside the bubble, as the leading edge of the bubble would be beyond the reach of a spaceship sitting at its center, he explains. The problem is that you need the energy to deform space all the way to the very edge of the bubble, and the ship simply can't put it there. Though he recognizes these huge hurdles to building a warp drive, Lentz feels they are not insurmountable. This work has moved the problem of faster-than-light travel one step away from theoretical research in fundamental physics and closer to engineering, he says. After addressing energy requirements, Lentz plans to devise a means of creating and accelerating, and dissipating and decelerating, the positive energy solutions from their constituent matter sources. Then confirm the existence of small and slow solutions in a laboratory, and finally address the horizon problem. This will be important to passing the speed of light with a fully autonomous solution, he says. Keep in mind that a warp drive has the ability to change the region of flat space-time it encloses. It can, for example, accelerate or decelerate a clock inside the drive. Consider what it would be like to possess such an item. Do you want to place someone who is dying on ice? Put them in a warp drive to slow down their time. A few years will pass from their perspective, while 100 years will pass on Earth. Enough time to find a cure. Even more extreme possibilities exist. By rotating space-time inside a drive, one might be able to create a battery capable of storing massive amounts of energy. Traveling faster than the speed of light might still be a pipe dream, but warp technology, on the other hand, would be revolutionary in its entirety. Let us know what you think about the new discovery of traveling faster than light down in the comments section. Remember to leave a like and subscribe to this channel for more interesting videos like this. Turn on your post notifications and stay tuned so you don't miss any updates from us. Until next time, stay safe.